This page of notes is meant to help you review the different methods we've been learning about for solving systems of linear equations. So please do pay close attention and take careful notes, as this page then will be very helpful as you're working on more review for your test next class. So one method we have used for solving a system is graphing. And when we use the graphing method, we are really just trying to find the intersection point of the two lines. So we're going to be graphing the two lines and then looking for where those two lines cross. And the way we've been doing this is we've started by graphing both equations by finding at least two solutions to each equation. And in a lot of the problems we've done, we've found more than two solutions, but you really just need two. You need two solutions, and those are coordinate pairs, xy pairs, that make each equation true, and then that'll help you graph the two equations. And then once you have a graph, you can identify the coordinates of the intersection point, and then that will be the solution to the system. So the example here that's given that we're going to revisit with all our solving methods is this system right here, 2x minus y equals 8 and 3x plus y equals 12. So those same equations are written over here, and I've already done some of the work for you for the first equation. So let's just look at the second equation and how we're going to come up with some points or coordinate pairs that are on this line. One of the easiest ways to find solutions to the equation, so find solutions to this equation, is to make one of the coordinates equal to 0. So I'm going to go ahead and just fill in the x coordinate as 0. Then I'm going to substitute 0 in place of x in the equation. I'm going to do a little scratch work and write that down. So if I replace x with 0 and rewrite the rest of the equation, now it's really easy to find the value of y. So 3 times 0 is just 0. 0 plus y equals 12. 0 plus y is just y. And then we know that y equals 12. So one coordinate pair that is a solution to 3x plus y equals 12 is the coordinate pair 0, 12. Another easy way to find another solution to the equation is to make the y coordinate equal to 0. So we're just making that choice to make the y coordinate equal to 0. So now I'll rewrite the equation substituting 0 in place of y. So 3x plus 0 equals 12. And let's see, 3x plus 0 is just equal to 3x. 3x equals 12. And then if I divide both sides by 3, we get that x equals 4. So the coordinate pair 4, 0 is another solution to the line or the equation 3x plus y equals 12. So now I'll graph those two coordinate pairs. Graph 0, 12, so 0 on the x up to 12 on the y, and 4, 0, that's 4 on the x and 0 on the y, and we're actually already seeing the intersection point. But now, ideally, with a straight edge, we can connect these 2 points together. I didn't use a straight edge, but you should. And when we connect those 2 points together, we do see that the point 4, 0 is shared by both of the lines. So that would be the solution to the system. So now let's look at solving the system a different way. Now we're going to use the substitution method. And the key to the substitution method is really to set the equations equal to each other. Now, in order to set the equations equal to each other, we really need to first make sure the equations are rewritten as y equals mx plus b. In other words, we have to get y alone, or y by itself, with everything else on the other side of the equal sign. Then, once we have y alone, we set y equal to y. Or in other words, we set the expressions that are equal to y equal to each other. You'll see what I mean here in a moment. Then we can solve for x. And then, after we have x, we can find the value of the y coordinate using one of the original equations. So make sure you have those steps written down. And then now we're going to really just annotate an example that's already been done. So taking a look here, this first equation, 2x minus y, has been recopied and then solved for y. And the method here that was used to solve for y was adding y on each side and then subtracting 8. And your steps might look different when you solve for y, but now we have this statement that's really important, that y is equal to 2x minus 8. So now we have one thing that we know y is equal to. And then with our second equation, 3x plus y equals 12. To solve that for y, you could subtract 3x from each side, and then y is by itself. Y equals 12 minus 3x. So now we have another expression that has the same value as y. So as the directions say at the top of the page, once we rewrite each equation as y equals mx plus b, then we set y equal to y. Or really, we're setting equal the expressions that are both equal to y. So this expression here is equal to y, and this expression is equal to y, so we can set them equal to each other. And then it's just a matter of solving the equation. We want to get x just on one side, so we added 3x, and then solve for x, and we get x equals 4. Once we have x equals 4, we're going to use that information and then use one of our original equations to then find the value of y. So we knew that x equaled 4. And then we can take, again, one of the original equations or even one of the equations that's already solved for y, and that's actually easier. So we take one of the equations, we take the fact that x equals 4, and then we can solve for y, and we get that y equals 0. So our solution is still the same as when we did the problem solving by graphing, 4, 0. So the last way we're going to review solving a system is using the elimination method. So the elimination method requires us to eliminate or get rid of a variable. If we can eliminate one of the variables, x or y, then it's easy to solve for the remaining variable, x or y. So to eliminate a variable and use the elimination method, we're going to make the choice to either add or subtract the equations together so that one variable makes a 0. So if we make a 0 by doing 3x minus 3x, or we make a 0 by doing negative 6y plus 6y, that variable is eliminated. And then we can solve for the remaining variable. And then once we have one of the variables, we can solve for the other variable, once again using one of the original equations. So again, make sure you have those steps written down, and then we'll see what that looks like for this system. So when we look at this system of equations, we want to look at the numbers in front of the variables, or the coefficients in front of the variables. For this equation, we see that we have a 2 in front of x and a 3 in front of y. 2 and 3 are certainly not the same number, and 2 and 3 also are not opposites. So right now, this system is not set up for eliminating x. So let's look at y. We have minus y and plus y. It seems like there's no coefficient, but really that's a coefficient of 1. So we have minus 1y and plus 1y. So our coefficients in front of y are negative 1 and positive 1. Now, negative 1 and positive 1 are not the exact same number. They're opposites. And if you recall from prior examples, if we have coefficients that are opposites, the key is going to be to add the equations together. So if those coefficients are opposites, you're going to add. If these coefficients were the same, like negative 1 and negative 1, or positive 1 and positive 1, then the choice would be to subtract. But since these are opposites, we're going to add together. We're going to add straight down. So we're going to add together, because that was our choice to add, 2x and 3x, and 2x plus 3x is 5x. Then we go to kind of our next column of information. We're going to add together negative 1y and positive 1y. And negative 1 plus positive 1, that equals 0. That variable is eliminated. We'll bring down our equal sign, and we have 8 and 12. And again, we made the choice to add, so we have to keep adding. 8 plus 12 is equal to 20. So now we have this nice simple equation to solve. 5x equals 20. We'll divide both sides by 5, and we arrive at the result, x equals 4. And then, just like before, once we have the first half of our answer, we've solved for one of the variables, we're going to go ahead and use one of the equations to solve for the remaining variable. So I think I'll rewrite the first equation, 2x minus y equals 8. And I'm going to go ahead and replace x with 4. 2 times 4 minus y equals 8. I'll simplify this equation a little bit and then solve. So 2 times 4 is 8. 8 minus y equals 8. And then now we just solve by subtracting 8 on each side. We have negative y equals 0. And then remember, a negative y is really like a negative 1y. So to finish the solving, we'll divide both sides by negative 1. Now, in this case, dividing by negative 1 doesn't do a whole lot because 0 divided by negative 1 is just 0. So again, even using this solving method, we still arrive at the same result, 4, 0. So as you're working today on some more review for the unit test, use this page of notes to help you help each other out, and just do your best as you try some more of these problems in preparation for your test.